Hello, good day, viewers. Today we have this question here, which says differentiate the function yz exponential x all raised to the power minus 1 when x cubed sine x squared plus 2 with respect to x. That is, we should find the f dx. So how can we find this? If you look here, yz exponential x raised to the power minus 1 is the same as 1 over yz exponential x. So we can substitute that here to make it easier. So f now equal to x cubed sine x squared plus 2 all over yz exponential x. So how can you find the f dx from this? Since the function is in form of quotient, we can try applying the quotient rule. In the quotient rule, differential of u over v with respect to x is v du dx minus u dv dx all over v squared. So now, letting this equal to u over v, that means u equal to x cubed sine x squared plus 2 and v equal to yz exponential x. So now, substituting into this equation now, du over v dx, which here is equal to df dx, is equal to v, which we have here to be yz exponential x multiplied by du dx. So what is du dx? We have u to be equal to x cubed sine x squared plus 2. Now we need to differentiate this with respect to x to have du dx. But how can we do that? Since we have x cubed multiplying to sine x squared plus 1, we can use the product rule, which we have dpq dx is equal to p dq dx plus q dp dx. Equating x cubed sine x squared plus 2 to pq, we can have x cubed equal to p and sine x squared plus 2 equal to q. Substituting here now, pq is equal to u from here. Now du dx is equal to p, which we have here to be equal to x cubed times dq dx. So what is dq dx? We have q here which equal to sine x squared plus 2. So what is dq dx from this? Here also we have to apply chain rule. Let's say x squared plus 2 equal to r. So dr dx will be equal to 2x by power rule. Since r equal to x squared plus 2, q equal to sine r. So differential of q with respect to r now is differential of sine r, which is cos r. So substituting now, dq dx is equal to dq dr times dr dx. dq dr here is cos r, which is cos x squared plus 2, and dr dx is equal to 2x. So dq dx now is equal to cos x squared plus 2 times 2x, which is equal to 2x cos x squared plus 2. So since we have dq dx now, we can substitute it into this equation here. So du dx is equal to x cubed times 2x cos x squared plus 2, which is 2x power 4 cos x squared plus 2, plus q, which we have here as sine x squared plus 2 times dp dx. So what is dp dx? We have here p equal to x cubed. So using power rule now, dp dx will be equal to 3 times x power 3 minus 1, which is 3x. So substituting here now, du dx is equal to 2x power 4 cos x squared plus 2 plus sin x squared plus 2 times 3x squared. Sin x squared plus 2 times 3x squared is 3x squared sin x squared plus 2. So du dx is equal to 2x power 4 cos x squared plus 2 plus 3x squared sin x squared plus 2. Since we have du dx now, we can substitute directly into this our equation. So now df dx is equal to yz exponential x open bracket 2x power 4 cos x squared plus 2 plus 3x squared sin x squared plus 2 minus u, which we have here to be equal to x cubed sin x squared plus 2 times dv dx. So what is dv dx? We have here v equal to yz exponential x. So what is dv dx from this? Here y and z are constant since we are differentiating with respect to x. So now the differential of exponential x is also exponential x. Exponential x does not change when you differentiate it. All over v squared, which is yz exponential x all squared. So now df dx is equal to yz exponential x open bracket 2x power 4 cos x squared plus 2 plus 3x squared sin x squared plus 2 minus x cubed sin x squared plus 2 yz exponential x all over yz exponential x all squared. Here we can factor out yz exponential x since it is a common factor. So now yz exponential x open bracket 2x power 4 cos x squared plus 2 plus 3x squared sin x squared plus 2 minus x cubed sin x squared plus 2 all over yz exponential x all squared. Here yz exponential x all squared is the same as yz exponential x times yz exponential x. So this yz exponential x now can cancel this yz exponential x. So therefore df dx now equal to 2x power 4 cos x squared plus 2 plus 3x squared sin x squared plus 2 minus x cubed sin x squared plus 2 all over yz exponential x.